Okay, we're going to do a little review of derivatives now that we know that velocity is defined as the derivative of position in time. So our velocity is the derivative of position in time. We need to practice with that. What is the value of velocity if I know a function of position in time? So let's go ahead and choose a case where, let's say, our position is equal to a quadratic, which would be some coefficient times time squared. Okay. So what would that be? What would the velocity, if this is the position as a function of time, what would be the velocity? So just a reminder of powers, derivatives of powers. Velocity would then be equal to the derivative of position with respect to time. Okay, and this is at squared, so derivative of a constant does nothing, so that's just a, comes out in front, and it's the derivative of t squared with respect to t, which, for a power, the power comes down, so we get 2t, and we raise the variable to the power minus 1. So in this case, that'd be 1. And that would be my derivative, or in other words, this is 2at. Okay. Now let's see what this means. This is graphically. So quadratics are square, and so our position is a parabola. That's what a parabola is our position versus time. Okay. That means that our velocity, according to this, is changing linearly in time. So if I were to draw my velocity, the derivative itself, just the definition of derivative, means if this is quadratic, then my velocity is changing linearly in time. Because it's linear in time here. Well, that's interesting, because acceleration is to velocity as velocity is to position, and we can see that from this line. That means if the slope of velocity is constant, okay, that means the acceleration value is constant, and so we get to kind of hint now at what acceleration is. The slope is equal to the acceleration. Okay, so acceleration is equal to delta v over delta t, and for things that are changing or non-linearly, or like no matter how v is changing, we could take that to the calculus limit and say it's dv dt. Okay. So we have the same relationship. Everything we talked about between velocity and position has the same relationship between acceleration and velocity.